Today I'm going to be talking about 3 points that have to do with the urinary system. And the first one has to do with the mechanism to control the GFR. The GFR is the glomerular filtration rate. And to understand better, you have the nephron, and the blood passes through. Inside the nephron is the glomerulus, where the glomerular filtration rate happens. Now, this is done by 3 ways. You have the filtration, in which you have the filtration membrane, and the plasma passes, excuse me, and what goes through the membrane is the filtrate. The second one is reabsorption, and you have the filtrate here, and there's some substances, some things that need to be reabsorbed and go back to the blood again because there are no waste, so that's reabsorption. And the last one is secretion. There's certain substances like drugs that are not normal to the body, or some, so those are waste, or there are some that are normal but they're the byproducts of metabolic processes, so those are waste as well, and those get secreted. Now, the glomerular rate is controlled. If it's too fast, what happens is it flows too fast, and then there's not enough time for reabsorption. If it's too slow, if it's the glomerular filtration rate is too low, then it's too slow, and too many waste get reabsorbed, and you don't want that. So the body has a way to control it. This needs to be controlled. So what happens is that this is done 3 ways. The first one is through renal autoregulation, in which the kidneys are able to control it without hormonal or nervous system. They do it all on their own. The second one is the sympathetic control. This could be maybe because of exercise or a condition that affects it. So what happens is the afferent vessels constrict, and the GFR and urine output get decreased. So this allows for it to go to the other parts of the body, like maybe the heart or the brain. And the third one, which is the also the second point I wanted to talk about, is the renin-angiotensin-aldosterone system. So what happens here is that there's a drop in blood pressure because of a condition. So what happens is, like, these receptors let the brain know, and the brain sends signals to the kidney to stimulate it to produce renin. Now, the renin is going to act on the angiostenogen to form angiostensin 1 and then angiostensin 2. Now, the angiostensin 2 has many functions. So one of them is for the vasoconstriction of the vessels, so it's going to raise the pH. There's another one, which is the adrenocorticoid. It secretes aldosterone. The aldosterone, what it does, erases the sodium, and also it helps with the water reabsorption. There's also the pituitary gland, which secretes HDA, adrenal antidiuretic hormone, and that this one helps with the water absorption as well. And then we also have the hypothalamus. The hypothalamus, it creates thirst on the person, so there's more water intake. Okay, so this is the renin-angiotensin-aldosterone system. Okay, I'm also going to talk about, and I have another card here, how the kidneys control the pH. I'm going to put it closer. So basically, the kidneys control the acid-base balance by controlling how much acid gets secreted in the urine. Now, it does this by the glomerulus it does this by secreting hydrogen, where other systems like the respiratory and others, they have a mechanism that has to be attached to something else. But this one, the hydrogen gets secreted by itself. But once it's secreted, then it's going to combine either with ammonia and it's going to be secreted in the urine, or with phosphate buffers, it's going to get secreted in the urine, or with bicarbonate and again secreted in the urine. It's a little bit blurry, but I hope it can be seen right here. Okay, so this is what I wanted to talk about, my 3 points. Okay, so thank you very much.